Okay, and okay, good evening everybody, or good morning, good afternoon, wherever in the world you are, and welcome to another LIDNUG monthly presentation. Tonight we have Shay Friedman, who's a C# and IronRuby MVP, and he's hopefully going to be teaching us some magic superpower tricks that not many of us knew that C# could do. As always, big thanks to our sponsors for their continued support of the LIDNUG community. Oxweb, without who we would not have LIDNUG.org, Telerik, PostChap and Pluralsight. Pluralsight have just come on board as a new primary sponsor for us, so I would like to welcome them to the LIDNUG family. We do have some events for you in the pipeline, but we don't have any confirmed dates yet, so unfortunately I can't list any upcoming events. But as is always, if you check with our LIDNUG events page on Eventbrite, once we have the details, they'll be posted on there. As usual, here's our links. The official group is on LIDNUG, group number 43315, or you can go to lidnug.org, where you can find download links for all of our presentations and any other information that you need to get in touch with the group. Our calendar feeds still exist and can be imported into Outlook. We also have our Twitter page on twitter.com/lidnug and the Facebook portal, facebook.com/lidnug. If you wish to get in touch with us, we can be emailed at info@lidnug.org. So, without further ado, I'll hand you across to Shay, who's going to be your guide for the rest of tonight's session. Thank you very much, Shay.
Thank you. So, hi everyone. I'll just switch to my desktop. Cool. So, hi everyone. Thanks for coming to my session, which is named What C# Could Do That? And this is my mission for today, to show you stuff that you didn't know C# could do. We'll see at the end if I manage to do that. I'll start by introducing myself first. So my name is Shay Friedman. I work at a company named Code Value, which I co-founded. I do training and consulting, and I write code and whatever they give me to do. I'm a C# or IronRuby MVP, and I'm the author of a book about IronRuby named IronRuby Unleashed, which is, by the way, the only book about IronRuby. So if you want a book about IronRuby, you're kind of stuck with me. Yeah. So if you want to contact me, please do not hesitate. My email is shayf@codevalue.com. My Twitter account is IronShay, and my blog is ironshay.com. You can contact me and ask me a question and whatever you want. So, what we're going to talk about today. The talk is actually separated into 3 parts. We'll start by looking at the dynamic keyword, which kind of makes C# a dynamic language. We'll then move on to talk about the DLR, the Dynamic Language Runtime, and Iron languages which were developed on top of that, like IronRuby or IronPython. And we'll end with some info about a project named Roslyn, or if you have heard about the term compiler as a service, then we'll talk about that in relation to all the dynamic stuff we're going to go through. Now, I will try to stop between these parts for questions. So if you have some questions, just write them at the Q&A window, and I'll try to stop and address them. Cool. So let's start. We'll start with the dynamic keyword. Now, the dynamic keyword was introduced in .NET 4. And the entire idea of the dynamic keyword was to allow stuff in C# to be executed during runtime and actually compiled during runtime. So you can actually do the resolution of methods, method calls, and field access during runtime instead of compilation. And this opened tons of new opportunities in C#. Now, I wonder how many of you have actually used the dynamic keyword until now. If you've used it, you can nod your head or something. I can't see you, but if I can come up with an answer to how many of you have used it, it's probably not a lot. And I guess that's because the dynamic keyword actually changes everything. And when I say everything, I mean everything. It changes the entire paradigm of programming. It makes C# a dynamic language, which is kind of the opposite of what it was before the dynamic keyword was introduced. And we all grew to love or hate, but we all grew to something, the static capabilities of C#. We know everything about it. We know how it works. We know all the glitches and all the good stuff. But we're not used to write in a dynamic mode. And this actually gives C# superpowers. And when I really mean that it gives superpowers to a programming language, because you can do stuff that you could never do before. And the thing about the dynamic capabilities of C# is that with great power comes great responsibility, as you all know. And I actually couldn't believe that I was going to tell you this sentence in a technical presentation, but it's a very good line. So, and it's actually true, because what I want to warn you about the dynamic keyword before we go any further is that you need to handle it with care, okay? Because once you start using it, it will change the way you think about how you write your code. People have been doing this for years in other programming languages, in dynamic languages like Ruby or Python or, I don't know, Perl or all these languages, and they are doing pretty well. But in C# we're used to one kind of paradigm, and the dynamic keyword is going to change it. And I'm going to show you a few of the practical uses, for me at least, that you can use the dynamic keyword. But again, look at it and just choose the places that you're going to use the dynamic keyword carefully. Just pick them very carefully. So let's dive into the code, and I'll show you several different demos about using the dynamic keyword. So we'll start with the first one, and the first one is about writing generic methods. Now, people in the dynamic world, like Ruby and Python, have been doing this for years. And for us, in C#, for example, or, I don't know, VB.NET or other static languages, when we write a generic method, we think it's generic. But when you see the generic methods that are being written in dynamic languages, you understand how generic a method can get. And with the dynamic keyword, you actually break this barrier that the capabilities of C# give you when you do generics and other stuff to write generic methods. And you can actually write much less code in order to achieve the same thing. So I'm going to show you a very simple but very powerful demonstration of that. So we'll start by writing a method which actually does a very simple thing that you cannot achieve today with generic, for example. I just want to add two objects. So I'm going to use dynamic here. Okay, so dynamic A, dynamic B. Okay, this is just like, if you haven't seen the dynamic keyword until now, so it just looks like a regular type, but it's not. It's much more powerful. So what I want to do now is just return A plus B. This is all I want to do. Okay. Now, the thing about this method is I want it to be as generic as it can get. So I want it to receive any object, and I don't care which object type that is. I just want it to use the plus operator on it and add these two objects together. And if these two objects support this plus operator, then I don't care if which object they are. I just want it to do that for me, to do this plus operator. And now I can do that with this method on every two objects that support the plus operator. So let's start and see that. So I can do now add 1 and 2 because these are two integers and it's okay. I can also do add 1.5 and 2 because it's also okay. They support the plus operator. And I can go even farther because this add method is as generic as it can get. So I can actually do add hello and world. And this is entirely legit. It's okay because strings can be added together. So it just works. Now I can even go even farther with that and do add, let's say .NET and 4. And actually you can write in C#, you can just add a number to a string and then the string will just be converted to, the integer will just be converted to a string. So we will get .NET 4. And we can do that because this single method allows this for me. Now, just to make it even more emphasized, I can take any class that supports the plus operator and use this add method on it. So I can write a custom class that does that supports the plus operator, and use this add method for that. So for example, I have this region here named fun class. I don't know why I call it fun class. I'm really bad with naming things. This is probably in every project that I do, the most challenging part for me is naming the objects and the classes. So fun class is the best I could come up with. Yes. Yeah, so fun class actually just has this data property, which is a string. It implements the plus operator. You will get two fun classes, and what you get is a new fun class with just the two strings combined together. That's the entire class. But now, with my add method, I can use it because it supports the plus operator. So I just give it a new func class with 1 and not func class, yes, and a new func class with 2, and that's it. Okay, and it works. Let's see that it works because you probably don't believe me by now. So I'll just compile, and this is actually just a console application, so let's just run it. And yes, it actually works. So we got 3 and 3.5, hello world, .NET 4, and 1, 2. So one method fits all. Yeah, this is very cool, and I can see practical uses for that here and there. Moving forward to the second demo. And second demo is about an object. It's called an ExpandoObject, if you've heard about it. An ExpandoObject is a class, a custom class, that returns a dynamic object. And then it gives some interesting capabilities to this dynamic object. So for example, let's just try that. ExpandoObject, by the way, has been introduced. It's a part of the .NET framework, and it has been introduced in .NET 4 as well. So ExpandoObject, and you see I create a new ExpandoObject and just put it inside a dynamic variable. And an ExpandoObject, I think it's called a state bag or something like that. It has a general name for this type of object. What you can do, you just create stuff inside this object just by calling it. So for example, we can do expando.message. This would be a property, and I just put something inside. So let's do hello. And when I write that, once during runtime we get to this line, this message property will be created inside this dynamic variable named expando. Okay, so I can just afterwards use it and just like it was declared during compile time. Now, I don't need to stop there. I can also add methods to this ExpandoObject. So let's do expando.print. Okay, and it will be an action which reads a string. Okay, and it will receive a message, and we will just write out yo, yo, yo. Yeah, this looks good. And we have a method right now. Yeah? Oh, let's add the message too, so we'll do something with this message. So this is a method, and now I can call it expando.print. And let's say, oi, oi, oi. Yeah. So, yeah, so we actually created kind of a class during runtime. We have properties, we have methods, we can actually create events here as well. So we can use this ExpandoObject to create classes during runtime. The only thing is that we won't have a name for them, and we cannot reproduce them, or if you don't have a mechanism for that. But this is also very cool. Let's see that it works, because I'm not sure you still believe me right now. So let's run that. So yeah, hello and yo yo yoi oi oi. Yes, it works. It works. So this is the second demo. Again, you can take advantage of that and do very awesome stuff. Demo 3, which is very, very practical in my opinion. Loading assemblies. This is okay practice, like loading assemblies and do some reflection stuff in order to load the types and then use the methods inside the types. Sometimes it gets kind of messy, and with a dynamic keyword we can make it much easier. And it actually, I sometimes call the dynamic keyword reflection on steroids, because it just gives you the fun on the power of reflection with the fun of dynamic. So it's pretty awesome. Here I just load in an assembly. Okay, this is just a DLL here that I wrote. I do something like a plugin mechanism. I load a type from this assembly, and now I want to use it. Okay, so the first thing I want to do is create an instance of this type that I just pulled off the assembly that I loaded. So let's do that and put the instance into a dynamic object. So this is dynamic, and let's call it obj. And now we use the activator to create the instance, right, with t. Okay, t is the type, right? And now I can actually go with the dynamic keyword here, with this dynamic object. I can just call the method inside. So I have a method that returns a string inside that. So let's just call this string message from plugin, for example, and then obj dot, and I can just write the method create message. This is the method I have in the plugin, and let's just write what we got from that. Okay, and that's it. Very, very readable, maintainable, whatever buzzword that you want. Much more readable than reflection code, if I had to do something like that here. And if that doesn't convince you, then just think about the next thing. When you have a plugin, right, you usually give the plugin implementer some kind of a DLL with interface or a base class or something like that, to give them the contract you want them to work for. I say you don't actually need that. Most of the time, if you have methods to just get regular types and return regular types, then you just tell the implementer, I need these methods to be in your plugin with these parameters. You give them a documentation or something, and you don't need to give them anything else. You don't need to give them anything like a DLL or something. You just get their assembly, use this mechanism with dynamic, and that's it. It doesn't have to be an interface or a base class or something, because dynamic just makes it much easier to do all this kind of stuff. So this is another good example of how to use the dynamic keyword. The fourth demo here is something that I got from a blog of a guy named Amazed Saint. He's awesome, by the way. I'll show you the link to his blog at the end. I got this from him and I just used it. And what he did something pretty awesome. He took the dynamic keyword, created a class that uses the dynamic capabilities of C# to read and write XML. Now, this is a killer feature for me, especially the XML writing, which I'll show you in a minute. So let's see that. The name of the object that he created is named Elastic Object. You can Google it and find it. And I'll show you how it looks like. This is just an XML. Okay, we have people here, and inside the people element we have person, and person has a name and a Twitter handle and a blog. Okay, pretty usual. And I don't know about you, but when I know that at the beginning of the day that I need to do XML stuff, I prefer to go and dive into my hot tub and kill myself. Yes. Do not try this at home, people. Anyway, the way to use the Amazed Saint Elastic Object is this way. This is the way to read the XML. You don't need any object. You just need this Elastic Object to use it. So it uses, this is the way you parse the XML. This is the link to XML thing. And the Elastic Object framework has this extension method named toElastic. And And toElastic returns a dynamic keyword, a dynamic object named people. Okay, this is the variable named people. And now I can actually go through the XML in a manner just like it was a regular type in my system. I will start by looking for all the person elements inside XML. And then you see every iteration I get a dynamic object. And in this dynamic object, I can just refer to the attributes just like they were properties. So you see person.name and person.Twitter handle and person.blog. Just like there were regular C# classes, and I didn't need to do anything, and I didn't need to create any class, right? Which is pretty sweet. Now, this is reading XML. Writing XML is much worse when you do it in hand. Look here. You see this dynamic here. You see I have a dynamic band, and I give it a new elastic object. And this is the name of my root element. Okay? And then I say band.name equals the scorpions, right? Yeah. Good band, right? Then I want to add some songs. So I call a method. I say band.songs.song. Okay, I create a new song, and then I give it a name, Winds of Change, and a length. And then I have another song, and I give it another name and a length. And now I want to create to export that into XML. And all I have to do is use this crazy syntax that the guy used with the greater than sign. So you get the band, this is the dynamic object, and use the greater than sign, and then format type.xml, and it just converts that to an link to XML element, and then you can just print it out. This is all you need to do to create an XML file. You don't need to create a class and serialize it or write it manually, which is not very fun. And I'll just show you how it looks like at the end. And you can see that these are the two lines from reading the XML. And this is the XML that we created, which is we have the band, name, songs, song, name, length. Everything is here. It was very easy. And this is, again, this is a killer feature for me. Just create an XML from objects without needing to create the object before. Awesome. Just awesome. Okay. So moving to the last demo about the dynamic keyword for now. And this is the more advanced example. And I want to create an object myself, a dynamic object myself. Just like the elastic object that the Amazsend guy created, or the ExpandoObject that Microsoft created. I want to create one myself and do whatever I want to do with it. So let's see that. I'll go here. And let's create a class, because we need an object, we need a class, right? So public class, log method call. Okay, this is the name of my class. Now, all the classes that return a dynamic object should implement some kind of dynamic interface or a class. The easiest way to create a dynamic object is to implement a dynamic object class, to extend a dynamic object class. You can also implement the iDynamicObject interface, but it will be a bit more complicated to do everything because you will have to do everything manually. Here, you actually just need to override whatever you want to achieve. So you can see all the methods you can override, like try convert, create instance, delete member, get member, invoke. Everything is here. If you override everything, you will end up just like a regular class. Now I want to override the try invoke member. Okay, let's delete that. And what I want to do, this is just a very basic example about that. I want to write to the console the names of the methods that are being called on my dynamic object. So I'll just write them, console write line. Let's do trying to invoke 0 and just give it binder.name. Okay, so this is it. I just need to add the result equals now because this is an out parameter, you can see, so I have to put something inside. And I return true. Okay, if you return false, the guy that calls this method will get an exception. The method couldn't be found or something like that. Return true, that means that the method was found. So I'm pretty much done. I have a dynamic object which will write out all my method invocations, all the names of the methods that I'm asking for. Let's try that. So let's do dynamic my object, and we'll do new log method calls. Okay, and now I can call whatever method I want. So I have my object. I can call test, and I can call my object dot hello. Yes. Let's just put a return here. Let's see that it works. We are at demo 5, right? And okay, so you see we get trying to invoke test and trying to invoke hello. So we wrote something, not very useful, but we wrote something. And now I want to show you something that is more useful than just writing out the names of the methods that you're trying to invoke. So let's remove that. And you probably saw this super finder region here. And if you've been using an active record, which is in Ruby on Rails, you probably are familiar with the method which is named findBy. You can actually, in active record in Ruby, you can query the database on a single column using a special method name. For example, you can call the method findById and give it as a parameter the ID. Now, the ID part of the method name correlates to the name of the column in the database. So you can go and do findById or findByName or findBy whatever name of column that you got, and then give it a value, and it will query the database accordingly. So I wanted to do that here in C#. And this was pretty easy with the dynamic keyword. So this is what I got at the end. I created a data table, okay, which has some data. You can see it here. Not very interesting. It has an ID and a name and some rows. Okay, one is the United States, two is Canada, and more. And now I created a dynamic object here, and I created a new superfinder dynamic class, and I provided this data table that I created. And now I can actually go and loop over my query results using a findByName method. Okay, find by name, and I give it Canada. Okay, and it will give me all the columns, sorry, all the rows that the column named name matches Canada. Now I can actually change it and give it like find by ID and change it to 4. Okay, and this will also work. Now I can go even further. If I had a column name, for example, continent, I can do find by continent. Okay, and give it like America. Okay, this will just work with what I did. Now you probably wonder how I did that. So let's go to the Superfinder class, and the Superfinder is here. So the Superfinder again extends the dynamic object class. It gets the data table in the constructor and saves it into a field. And then I override the trying both member method. And the first thing I try is I try to understand if the method name starts with find by. This is what I want to use here. If it doesn't start with find by, I just tell it return base. Do whatever you want to do with this thing, throw exception or whatever. But if it's find by, I continue. It starts with find by, then I take the rest of the name. I just remove the find by from the beginning, and I get the value. I add just columns if the value is a string, and then I just use the data table select method to create kind of a query with a column name that I just pulled off the method name with the value. And that's it, right? This is very simple. This is all I had to do in order to get to achieve what I just showed you. Very simple and very powerful, and I'm sure you can do much more with that. Just you know how to do this now, so go ahead and go crazy. Yes. Okay, so this is the dynamic part of this session. I see I have 2 questions. Well, I'll just address them, and if you have questions, just ask. Okay, is this only restricted to C# or please go to VB.NET too?
Click on the Manage tab, Shay.
To manage?
Yeah.
Oh, okay, right. Does the dynamic approach have performance complications that you should be aware of? Yes. Just like reflection has complications, dynamic keyword does everything during runtime. It has performance mechanism, like several different caching capabilities, which make it work faster when time goes by. But yes, it does have some performance complications. If you're doing real-time applications, I don't think the dynamic keyword is good for you, but otherwise it won't be that slow. It's actually kind of fast. Okay, which format types do exist, and are there any of them that doesn't really work as intended? I'm not sure what you're referring to here, but I guess it's about the elastic object with the format types, the one that I showed you here. I guess this is what you're referring to, and it actually supports just XML right now, if this is what you're asking. But this is open source. It's just you can download the source, you can change it, use it, whatever. So this is all you need to do. So if you don't like it, just change it. Okay. Okay. So Yes. More questions. Okay. Where can we find all the demo code for download? I'll post all my all the demos that I show you here. I'll just upload them to my blog, and if LIDNUG has some kind of place, that I'll give them this too.
We can put them on lidnug.org once the presentation's finished.
Sure. So this is where you'll find it. What about using dynamic types in async code? Is it possible, and if so, is it any more dangerous than non-async code? I don't see a problem with that. If you want your dynamic object to be safe, thread safe, I think you probably want to implement that yourself with lock mechanism or some other mechanism, but it's just like any other code. Think about doing reflection in async mode. Might be the same thing, so it's about the same thing. By the way, what I didn't say about the ExpandoObject that I showed you before, if some of you are doing ASP.NET MVC work, then you probably know ExpandoObject, because if you ever use the viewBag property in ASP.NET MVC, this is actually the ExpandoObject right there. So this is maybe the most popular use of the dynamic object in a big framework. Okay, so moving on. Oh, okay, last question. Will you choose DLR like a prime approach on real production code on client side, or it will remain like powerful complementary tool to enhance capability of static type platform? Well, that's a big question. I could talk about it for hours. I can say, just like I said before, you should use dynamic wisely. I will talk about the DLR in a second, and I will show you where you can actually use the DLR itself. But talking about dynamic, in several different occasions, I think it's totally legit to use it, just like the elastic object, using it to write XML. Or if you find yourself writing tons of methods, just overload methods, maybe it's time to move to a more dynamic approach instead of writing hundreds of lines. If you can save a lot of lines of code, you can use it. And also writing dynamic objects yourself. This is maybe the most powerful thing that I'm familiar with in C# right now. You can actually do whatever you want there. So this is kind of the superpowers that you get. And just like every other superhero, use them wisely. Yeah. Well, I'm moving forward to the next part. If you still have questions, just ask them afterwards. Okay, so moving forward to the DLR and Iron languages. So the DLR is a dynamic language runtime, and the dynamic language runtime is actually very similar to the CLR. It's a component. It's written on top of the CLR, and the idea is to provide a common runtime for dynamic languages. So people who implement dynamic languages and they want to implement them on top of the .NET framework can do that more easily than it was before. So this is the idea of the DLR. And the DLR has three main components inside. Probably have seen this slide before, but it's very good, so I'm using it again. The first thing about the first component about it in the dynamic language runtime is the expression trees. All the code that you write gets converted to an expression tree, which then gets executed. So everything goes there, becomes an expression tree, and gets executed. Then if you're trying to call something outside of the expression tree, outside of your language, you're using a dynamic dispatch thing, which uses binders. Now, if you're calling .NET from your dynamic language, then you'll use an object binder. And if you're calling JavaScript, you're calling Silverlight, then JavaScript binder and Python binder for Python and Ruby binder. You see that everything here, because of all these binders, you can actually call everything from everywhere, and it's very convenient. You can actually call Python code from Ruby, and Ruby code from Python, and .NET from Python, and Python from .NET. Everything lives together in big, lovely harmony. Yeah. So this is the second thing, the dynamic dispatch. And the first thing is call-side caching, which is a performance mechanism to make these languages run faster. So if you have some block of code that you call several times, this code gets compiled the first time and then it's cached. And then the second time, it doesn't need to be recompiled. So the longer you run your application, the faster it gets. So it's pretty sweet. Now, on top of the dynamic language runtime, Microsoft started writing IronRuby and IronPython, which were implementations of the Ruby language and the Python language on top of the .NET framework. Now, Microsoft, at a certain point of time, about a year ago, decided to move this away from Microsoft, and now these both languages live as open source projects. So if you want to contribute, you can go ahead. I'll show you the links at the end. IronRuby and IronPython are both open source, not run by Microsoft right now. They're still alive. You can use them, you can take advantage of them, and you can contribute to them. Also, C# and VB.NET take services from the dynamic language runtime, and other languages were written also not by Microsoft, like IronSkim. I heard something like that. IronJS, which was a JavaScript implementation. I'm not sure what happened with that, but it still exists, I think. I just know it was written in F# on top of the DLR, which is kind of crazy. And also, I found that LOL code, I don't know if you're familiar with that, but this actually works. Someone from the DLR team back when they were developing the DLR created that. It runs. This is programming language. Hi, say code start. I has a fish, it's yummy. It says fish equals yummy. Visible hi world says console write line, hi world. I'm in your loop, loop start. K thanks, loop end, and K thanks by is code end. Okay, so this is a programming language. LOL code is actually, if you look for it in Wikipedia, it's actually a programming language. Someone came up with it. So this implementation actually works on top of the DLR. So if you're looking for bizarre languages, we got them too. Yeah. Let's see some demos. Note of LOL code, I don't have this implementation here. Yeah. So the first thing I want to show you is something that I find very powerful. So let's set that and run. I have this rule engine here. I give it a value and I click and validate. Now I can set up. Oops. Well, okay. I can set up the rules for that. So I can do numeric or textual, and for numeric I can add minimal value and maximal value, and I can also go in textual rules and give it max length. So let's do like, let's go with numeric and give it an 8 and save, and we'll go with 1, which is okay, and 9 will be bad. Okay, this is the great rule engine application that I got. Now, we all love our customers, right? Everyone say right. Good. There are nice people who always like what we give them, and they never want more. Not. Yeah. The customers always want more. And they will always find the weirdest things to want. So they will come to you with this rule engine and they will tell you, no, I don't want this validation just to be about max length for strings. I want that when the user puts C as the first letter, I want it to be invalid. Why? I don't know, but this is what I want. Now add it to your software. Now what I believe is, I believe in giving power to the people. So I say, give them the ability to write their own validation rules, and you just rest and drink beer and have fun, right? This is a great plan. So, in this rule engine, I have a custom rules text box, which gets Ruby code. Okay, this entire WinForm application is written in C#, but I'm going here to take advantage of executing IronRuby code inside C#. So I can give this ability to my customer. I can tell them, okay, you want C to be the first letter that invalidates the entire thing. So, okay, just go ahead here in the text area and just write your code and do whatever you want. You want even more crazier ideas for validations? You go ahead and implement them. I don't care. I gave you the framework. Now do whatever you want with that. So I can write here just Ruby code. So let's do if value f0 equals C, right? Then return false, right? Else return true. And this is Ruby, right? And just save it, okay? And now when I write something like that, it will be okay. But if I start with a C, it won't be okay. If I remove the C, it will be okay again. So it actually works. And you're probably thinking right now, well, that's cool, but you probably spent 3 weeks to implement that, so I don't want to do that. But no, this is very, very easy using IronRuby. Or IronPython, by the way. Let's see the code. So, the code. All I needed to add in order for that to work is that. 3 lines of code. That's all I needed to add in order for that to work. Okay? There are no more lines. Maybe one using line, but that's it. 3 lines of code and then it works. What I do here is very simple. I create an engine. This is the heart of the language. This is where all the magic happens. By the way, if you like Python more, then you just add the IronPython references, and then you write IronPython.python, and everything else is the same. Okay, so it's kind of the same. You can choose the one that you like more. So I create the engine. Then for the actual code, I need to expose the variable that I want the code to be able to use. So I create a variable there named value, and I just put the text from the text box inside this object. Then I just execute the code, and I'm pretty much done. Okay, I execute the code. This is the code from text box, and I get back a Boolean value, and that's it. 3 lines of code, and you can go rest, drink beer, and enjoy life. Yeah. Yes, yes, yes. This is what being dynamic means, by the way. Yes. Another demo, which is kind of more funkier. This is it. This is where I use Ruby classes inside C#. Now, Ruby has its own capabilities, its own set of features, and it's, in general, a more powerful language than C#. You can do much more there. Some people say you get too much power in Ruby as a programmer. Some others like it. I'll give you to decide that. But what I do here, let's see, I have a recorder class. This is Ruby. Okay, this is a Ruby class. And this recorder class does 2 things. It records your method calls, and then after you're done recording, you can play back these calls that you made on some object, whatever object that you want. Okay, this is the implementation in Ruby. I'm not going to get into that, but it's very simple. There is no more lines there. There are 3 different methods, and that's it. Very simple. And now I want to use it inside C#. So I'm going back here. I have this engine again, IronRuby engine. Then I load this recorder class into the engine. Okay, now it's available for me. And in order to use it, I need to create a dynamic object and insert the engine runtime globals property inside. And now the entire Ruby context is available for me. Okay, so now I create an instance of this recorder object, recorder class inside C#. Okay, I created an instance of a recorder object, which is written in Ruby inside C#. This is what's called seamless integration, right? Now, in Ruby, to create a new class, you don't write new recorder, okay? You write recorder.new, okay? So because of that, I need to do this thing here instead of just new Ruby recorder. And I use the @ sign because new is a reserved keyword, so I can just write it there. That's it. I created a recorder instance. And now I'm going to use it like it's a regular object, a C# object, I don't care. And let's record stuff. So we can do add 1 and add 2. Okay. And now we have that, and now I can actually play back these calls that I've made on an actual object. So let's create a list of int. List. Okay, and I have a list of int. And now I'm going to play back these 2 method calls on this list. So recorder.playback. This is a method inside the Ruby class, playback. and I'm giving it a list of at least this is a .NET class, right? So I gave it a list, and just let's go and do for each, for each int I on list. Yes, so I want to write it out, I. Okay, so that's it, right? I'm kind of done with my recorder. Let's build that, and it's demo 6. So let's run it, and we should get 1 and 2. And yes, it works. So we just done this recording, and we actually can do some more stuff, not just one parameter, for example. So let's create again this recorder class. I can go and do, for example, recorder dot write IronRuby, yes, and recorder dot write line and .NET 0 4 2 parameters, right? Recorder dot write line are the bomb. So I'm done recording now, right? And I can playback. So recorder dot playback, and let's say console dot out. Okay. So what it's going to do now, it's going to call console.out.write with IronRuby, and that's console.write.out.write line, and give it the 2 parameters here. And at the end, just again, write line are the bomb. Okay, let's run it again. And yes, IronRuby and .NET 4 are the bomb. It works. So it was very simple to create. Like if you combine all the lines of code of the recorder class and the C# code, it's like, I don't know, 20. And this is a very powerful thing. To record calls and run them again. It's very powerful. Okay, so this is IronRuby and C#. There is much more about IronRuby, but I'm not going to talk about that today. So I'll move to the questions now, and then we'll move to talk about Roslyn for a bit. So, questions. Yeah, my process monitoring here is Process Explorer. This is the thing. It's not related to presentation, but yes, this is Process Explorer. You can download it. It's Microsoft thing. Yes. If you have any more questions, the time to ask, and then we'll move forward to our screen. Okay, I'm moving forward. And yes, Roslyn. Roslyn is very, very new. It was released as a CDP about 2 weeks ago, or maybe a bit more. It's very, very early, in a very early stage. Okay, a lot of stuff doesn't work, and they still have some things to accomplish, but it does work right now, and you can do very cool stuff with it. The idea about Roslyn is that it's what's called compiler as a service. Up until now, until Roslyn came, the compiler was kind of a black box. You give it code, and you get back a DLL, right? Now, you couldn't do much more than that. That was it. Very black boxy. Roslyn tries to change it. Microsoft has been working on that for, I think, years. I've been hearing about it for years, and it's finally getting getting actually released, Roslyn actually built of 4 different parts. The compilers, which allow you to get a bulk of code, and you can analyze that semantically or other way of analysis very easily. You just get an API and you just go through the code and read it and do whatever you want with it. Like, you get syntax trees, so you can change them or do other stuff, refactor very easily. So this is the compilers part. The scripting part is the way you can compile things during runtime, because you have the compiler as a service. You can call the compiler during runtime. So we will see, this is what actually is related to this talk, and we will see a very cool thing that you can do with that. The first thing is workspace, which is all the APIs that are related to handling the solution file. You can create solution files, you can change solution files, you can add files to the solution, to create projects, add reference, add files. Very convenient for mostly plugin creators or Visual Studio extensions. And the last thing here is what's called services, and this is just a very easy way to create add-ons to Visual Studio. This is something that is related just to Visual Studio, and you can create add-ins. You can create add-ins that mark words like ReSharper does, and do other stuff that they try to make it easier for you to create add-ons. Especially the ones that analyze code will be much more easier to accomplish now. It won't be easy. It will be easier. Okay, so the ReSharper guys still have their job secure. Okay, so I want to show you some samples of that. Let's go here. Okay, so the first one is actually demo 2. Okay, I'll just run that first. And what we get from this demo 2 is a list of using directives of the namespaces. What did the code do? I'm using here something that is called syntax walker. Okay, this is actually a sample that I got from the Roslyn documentation, and just see what it does. We get the code as a string. Okay, we have some code here. You have using in outside and using inside namespace, and inside another namespace, a lot of using. Now, what the code does is actually works on this, all of this code, gets the using statements out of it, and then I just print them out. The ones that are not that do not start with system. So, for example, here, I just use this class named using collector that I created, which gets me a using list, and I can just go and write it out. What it does inside, this is the interesting part. It just extends a class named syntax walker. This is a part of Roslyn. And what it does, I override a method named visit using directive. And then I just get all the using directives inside the syntax as the Roslyn API goes through the syntax. And I can just filter all the ones that start with system dot, or they are equivalent to system, and if it meets these criteria, I just add them to the list. So this is, again, a very simple implementation here, but you can see the power of Roslyn and what you can do with that in certain occasions. So this is one thing, but I want to show you something that's much more cool. And let's change that to demo 1 and run it. And this is C# REPL console, which is just like the dynamic languages. They have this interactive console. They can write code inside, and it will get executed right away. Now C# got that too. So I can write here console.writeLine hello, and it will get executed because I can take this console.writeLine hello, this line, give it to Roslyn, tell it to compile that line of code, and then I get it back as a code and I can execute it. That's it. This is compiler as a service. This is what it gets. This is what it gives you. So I can go ahead and do like var I equals 4, and then I plus plus, or I plus 5, right? And I can even create classes. I can do class test. And do public void say hi system.console.writeLine hi, and now I have a class and I can actually create an instance of that. So var t equals new test and t dot say hi. It's very cool, right? This is a REPL. REPL is read a value at print loop. You write the code and it gets executed immediately. You can actually do even system.windows.forms.messagebox, for example, .show. Hi. Yeah, we're saying a lot of hellos today. And it shows you a message box. So yeah, this is a very cool thing that C# is now got, and it's not it's very limited at the moment, but it will get better. And I'm not sure what the roadmap for Roslyn is, but if they got the CCP out already, then I guess that in the upcoming year we'll see this in RTM. I have no idea, so do not write my words and then come and ask me for that. But it's actually pretty much there. So now we just say bye bye here, and it ends. And actually, this doesn't come with Roslyn. I actually wrote the code. It's not actually me. I just took the code. Remember Amazed from the beginning? I saw his blog and took his code and changed it a bit. So he is pretty much responsible for this code. So thank you, Amazed. As you can see, this is the code that runs this interactive console, and all it does, it has this scripting host class that I use. This code just does this while loop until you say bye bye and it ends. The scripting host class is something that I wrote here, and all it does is also very simple. It has a session. Roslyn has session, so you create just a session, create a script engine. You can see that the terminology is very similar to what you saw in IronRuby, right? It's very, very similar. Here I load some assemblies that the code can use, okay, and do some usings for the code. So now I have the engine and the session. This is it. And now I have an execute method that just takes the code that is written and executes that using the engine on the current session. So you can also have several different sessions on a single, a single project with Roslyn. So that's it. That's the entire code to write a REPL in C# with Roslyn. The cool thing about Roslyn CDP is that once you write it, you get this. You go to View, Other Windows, C# Interactive Window, and you get an interactive console inside Visual Studio. So you can do things here also when you get IntelliSense. So you can do console write line, hello, and it works. Okay, and you can do int I, it's like before, and you can write I, and it will tell you that what it is, I++, and again, just like before, and it's inside inside Visual Studio. I'm not sure what you're going to do with that. Maybe just to try some things out. I couldn't load anything here. Like if I want to load my own assembly and try it out, I couldn't do that here. But from the code that I showed you, you can just add the assembly there and it will be available inside your code. I'm sure there will be a way, or maybe there is right now, and I just don't know about it. But this is very cool, right? An interactive console, just write code and it will get compiled and run immediately. So yes, this is Roslyn. So let's take some questions and we'll wrap up the session. Okay, 3 questions. Okay. Can you use Roslyn to add a debug window to an application to allow looking at methods and properties of the application at runtime without being connected to a debugger? I guess. I'm not sure. But I saw there is a sample on the Roslyn site about adding this interactive console into a WPF application. So I guess you can add something like the interactive console, which allows you to investigate your code through this console, and you can add it to a live-in application. So I guess you can do something like that. And by the way, you can also do that with IronRuby and IronPython. If you're into that, this I know for sure can be happening. So yes, it's possible with them. Roslyn, I guess, but I'm not sure. How can you prevent malicious code from running using Roslyn? I'm not sure I understand the question. I'll answer what I think that you're referring to. I guess that if you're writing something like execute format C inside this interactive console, then what you're gonna do. This is just code. You can give it, you can use all the code access security or all the other security methods that you know in C# to prevent it from running stuff that you don't want it to do. You can also just, you control the code that runs this interactive console. So you can just find some method calls that should not be there, in your opinion, and just remove them. Yeah, that's it. Okay. Do you think such a code is supportable enough? I'm not sure what you're referring to. I'm sorry. If you're referring to Roslyn, and Roslyn is in CTP, so just use for RTM before you start really using it.
I think looking at the questions and looking at what's coming through, I think what Vadim's referring to is code written in such a dynamic way with the dynamic types as you've demonstrated to us. I think he's worried about the support aspects of that code. For example, if you're supporting static code, you know that it's integers, you know that it's strings, and you've got your support guys that can look at the source code. But with dynamic types, I think he's referring to how easy is it going to be to support for the support guys, you know?
Yeah. Okay. So I'll answer that. Writing just like I said, the dynamic keyword changes everything. It changes all the paradigm, the programming paradigm that you're familiar with, which, just like you said, with static language, with all the static types that you got, you know where everything is, you know what it's supposed to do, and the dynamic keyword kind of changes all of it, and you kind of feel in the air. People in the Ruby and Python land have been doing this for years, and they're pretty happy. And what they do in order to keep their code safe or supportable is to write tests. The amount of people writing unit tests in the dynamic languages world is pretty high. Like, I don't know the percentage, but I guess it would be more than 50%, which is a lot. That might sound not a lot, but I guess in C# it's like 10% maybe. So you just write tests, a lot of tests to support your code, and this is just a different way to look at things, because you say, when you think about it, compilation doesn't really give you the support that you need, because it just says that your code compiles. It doesn't mean it actually does what it's supposed to do. And when you write tests, you actually make sure that your code does what it's supposed to do. So it's not a bad paradigm to write, to kind of be enforced to write tests before you write your code, in order to make sure that your code actually runs.
Absolutely. I mean, I know just from my own experience that a huge amount of the TDD strategies that we see in the .NET world these days actually come from open source projects such as Ruby and Python and PHP and languages like that. I myself, I do quite a bit of PHP as well as .NET, so I know the landscape, so to speak.
Right. So yeah, that's exactly what I'm saying. Okay, so no more questions. I'll just wrap up.
Do we have any more questions, guys?
No. I'll give the summary, and if there will be more questions, I'll just get back to here. We'll see. Yeah, let's see what we talked about today. We started, the first part was about the dynamic keyword. We saw several different things that you can actually do with the dynamic keyword. You saw the superpowers that you get when you do that. As I said, use it with care. Be careful, because superpowers should not be handled without care. We then moved on to the DLR. So a couple of different examples of what you can do with DLR languages. I showed you IronRuby, but you can do everything that I showed you as well with IronPython. So this is where these walls collide, and you can use what you want from the Ruby or Python world inside .NET. This is very, very powerful. And the last thing I showed you is Roslyn. Still, it's very early stages, but you saw the capabilities of that. I'm sure you'll be hearing about it a lot in other events. I guess you will hear about it here in LIDNUG as well later. And I'm sure people will find good uses to that. And you saw that the REPL window, the interactive console, this is great. It will, I can see a lot of use for that. About resources, what I was talking about. About the dynamic keyword. Am I back?
One, two, three. Shay, can you hear me?
Yes.
Oh, excellent. Looks like we have sound again. Sorry about that. I think a lot of people suddenly got hit with sound issues. Yes, please continue.
Okay. Okay, so I'm not sure where I was cut off, but the resources for everything I was talking about. The dynamic keyword, I found a great article in Visual Studio magazine, so you can go there and read about it and what it can do. If you want to download and try out IronRuby or IronPython, then ironruby.com or ironpython.com. For Roslyn, just go to the site here, msdn-microsoft.com/en-us/Roslyn. Everything is there. You can download the CTP. You can read the documentation. So everything is there. And Amazing, which I used a couple of samples from his site. So thank you for that. So let's address the questions before we wrap up. Yes. Okay. How much IntelliSense is supported in VS for these dynamic languages? Okay, so dynamic languages have kind of no support for IntelliSense. In Visual Studio, you actually in Python. Python has pretty good tools there. So you have like a very basic IntelliSense abilities, but you don't have to use Visual Studio for that, because Python and Ruby have different IDEs that you can use, because IronRuby and IronPython are just implementation of the Ruby and Python languages. So you can use other IDEs that maybe support IntelliSense better for these languages. But Python has pretty good tools for Visual Studio, so they have some kind of IntelliSense. And Ruby also has some tools for Visual Studio, but it has a very, very, very basic IntelliSense support. Okay, so yeah, so thank you very much for attending. If you want to contact me with more questions, just go ahead, shoot me an email, or through Twitter or my blog. That's it. Thank you very much for attending.
Thanks very much for doing the presentation for us, Shay. It's been quite enlightening.
Thank you.
And I trust you'll consider coming back in the future and doing a follow-up to this one.
Of course.
Fantastic stuff. Folks, sorry about that little glitch. My audio took a nosedive right in the middle of me talking, and I still have no idea what, where, when happened. I trust that Asset managed to keep recording, and Brian was ready to step in just in case. Just to let you guys know, we have a new sponsor on board, Pluralsight, and after each show for, I think it's the next year at least, we will have some free Pluralsight training sessions to give away. So those of you who have registered your email address when you've come to register for the session, we will be drawing email names at random after the presentation is over, and we'll announce within the LIDNUG group and contact those that have won to send them their free Pluralsight subscription. If you have any questions about that, feel free to come into the group. As is always, the links are on here when things start working. As always, the links are on here. I'll leave them on screen for a few minutes for those who want to write them down. And please do come and visit us in the group. Get some conversations going. Come and discuss Shay's presentation with us, and let's see if we can get some dialogue going and maybe even some code samples in there. We'll get the code from Shay.